Oh, hello, I think I'm live. So let's start the stream. Let me let me tweet about it first. Hopefully some new people will join. Let's see. Quote. Okay. Yeah. Now that's done. Let's get back to our stream. So yesterday we were like testing stake manager and we were testing withdraw stake. We have these three we have these three conditions that we wanted to test: one, two, three. And then if it works properly, that was the fourth condition. And fifth was sending to contract that will fail on ether received. So our next step is like checking if withdraw stakes works properly. Withdraw stake function, that's the plan. And then we can go up and see if we have the revert. Yes, we do have revert, but it's only for simple account. We don't have we don't have general contract that reverts, so we can create one. Revert on ETH. Oh, why am I seeing this? Yes, we do have one. Then we don't have to create this. Sorry. We can use this contract to send ether and it will revert. Let's copy this and go back to our main function. Uh, no, not our main function, our test function. So fun- function test withdraw stake works public. Now first is add stake, then unlock stake, then we have roll the timestamp, that's the next step, then withdraw stake, assert, do the assertions. Is the spelling correct? Hopefully it should be. No, assertions, there is no ta. Assertions. We can also say like tab 0 create receiver, because we can withdraw stake to any receiver It doesn't have to be the entity that is staked. That entity can withdraw stake to any address. So we can start with creating the receiver, which will be payable address. We have done this yesterday, where we used make address and wrapped it in payable. Next is add stake. Okay, we also need to create the variables. UN256 stake equal to 1 ether. Now UN32 unlock, no, unstake delay seconds. We can set it to 100. Now we can add stake, add stake, unlock delay seconds, and pass the value stake, not unlock, it's unstake, unstake delay seconds. That works. Now we need to call entry point dot unlock stake. That's done. VM dot, let me go to this Foundry book, Solidity. Yeah, I don't remember the cheat code. I remember the cheat code. I just don't remember how. Role. So we need to, no, role is for increasing the block number. Warp. So that's for timestamp. Okay. In here, not deposit. No, not withdraw. Here. Yes. So withdraw. Here they set this log.timestamp to UN48, and then we add this to UN48. I don't know how this will work basically. Sorry, not how this will work. How this will behave. What happens here? Like if a block.timestamp is, oh sorry. So we saw warp, like the cheat code in the Foundry book, but I was checking here. So we want to warp the timestamp, and then here I was talking about this function. It's checking withdraw time, which is getting set in unlock stake function, and I I don't know how this line will behave. So if we have timestamp like this, okay, so it should stay same. Yeah, let's try. Let's just try it and then see. So warp, we can say 101. Let's create a not a variable for new timestamp equal to 101. New timestamp. Now let's go here. We say entry point dot withdraw stake, and we can give receiver to it. We can give receiver to it, and do the assertions. So in the assertions we need to check. Let's go in the stake manager. We can get the stake deposit info for the account and then check what's the deposit. We know like how deposit, no, we can check the stake from deposit info struct. The amount should be 0. So let's get our stake manager mem dot deposit info memory deposit info equal to entry point dot get deposit info for address dot this address of the contract. Then we can say assert equal to deposit info dot stake and say it is 0. UN256 expected stake after withdrawal. Expected stake after withdrawal. Okay. Now next part is assert equal to receiver dot balance should be stake. What else? Yeah, we also need to check if we are getting an event. It is emitting an event or not. Expect emit. We need to go to our stake manager and stake withdrawn. That's the function. That's the event which is getting emitted. Stake withdrawn, which has one indexed, two non-indexed, and we know all the parameters. So we can say true, false, false, true, and then the address of entry point from which the event will be emitted. Then the actual event stake manager dot stake withdrawn, say account. So address this, withdraw amount will be, no, withdraw address and then amount. It will be receiver, and then the amount is stake amount. Okay, yeah, that should do it. Hopefully it will work. Let's run the test and see. Okay, let's see the trace. So we said you can see the event which is correct. We can see the first assertion which is 0 0 and second assertion which is 1 1, 1 ether 1 ether. Now that's done. We have to do same thing but with revert. Do no, we don't have that. Yeah, this for this function. So next will be function test with withdraw take withdraw take reverts on failed ether eth transfer. You can say yes. Public will do the same thing. First set variables for receiver stake unstake delay seconds. Then we can add unlock and no add an unlock stake, also change timestamp. So for here we also like new timestamp. Okay, now here do the assertion and withdraw stake. Let's go. Address payable receiver equal to, should we do this new reverts on ether received. Okay, no, okay, can we say, can we do this, can we do this then? Yes, we can. We just need to wrap it in payable and the address. Then stake, then unstake delay, and new timestamp. Okay, that's done. That's done. Let's add stake, remove stake, not remove, unlock. Unlock stake, unstake delay seconds, and pass the value. Then entry point dot unlock take vm dot warp new timestamp. I think we can do like vm dot role also to 1 or 2, whatever. It doesn't affect the structure. Then we do vm dot expect revert. We are expecting revert. We are expecting a custom error, not not custom error, but just like bytes, a string. And then we do withdraw, sorry, entry point, dot withdraw stake, and give it receiver. Okay, so now that's done. Yes, it worked. Let's see the trace. Yes, you can see it's working properly. I don't know what else to say, but it's working properly. Okay, that this whole function is completed. Let's check. Yeah, we can check our coverage. Let me switch back to local host. Oh, sorry. I need to start localhost. Yeah. So here, core stake manager. We have done this. Yesterday we were in red. Today it's yellow. We need to move this up to like 90%. Back to VS Code. With this function, if you complete like test for this function, it should go down to go up to 90%. Okay, let me take a break. Okay, I'm back. Let's write test for withdraw, and there are three conditions, right? One is testing for this branch, this require statement, then this require statement, and actual test for the function, like to check if function works properly and emits the correct event with correct data. So what we can do is, let's write here. Should we just move all of these tests? Okay, let me do like forge coverage. Okay, remove this. It's formatted correctly. Total we are up to 60%. Okay, I don't understand why test.t.sol is covered under it, but we need 100% for all of these contracts. Yeah, our sample contracts are tested 100%, like covered 100%. The base account is covered 100%. Nuns manager is covered 100%. And now we are aiming for stake manager. Next, maybe user operation lab. Let's see what gets, and we can't touch this because it's an internal function. This is also internal function. This is also internal function. Okay. Oh, it's a lab. It's a library, so we can test it. We can just like use it in some test contract, create, and then try to use it here. Uh, Try to unit test it. Okay, yes. Let me see where it is used. References. Yeah, it's getting used in entry point. We know that. It's also getting used in base account. To do what? That's my question. Where it is getting used? Oh no. Yeah, it's a library. We have access to those functions in those contracts. Okay, let's aim for withdraw. Uh, let's aim for 100%, not 100%, but more than 90% coverage for stake manager on the for this tree. Let's go back here. Function test withdraw to reverse on what was the first condition? Deposit is to deposit amount too large. Oh, withdraw amount too large. Okay, so it's asking more than the deposit. Okay, now that's done. What else? What was the first thing? We need to add deposit. Let's go back. Okay, it needs withdraw address and withdraw amount, but it also needs a deposit, right? So if deposit is 0 and we are withdrawing, it will throw this error. Okay, yeah, we don't need, and the withdraw address is payable. So create receiver. Just a second. Okay, create a receiver, payable receiver, and then withdraw deposit. So also this function is for deposit, not stake, so keep that in mind. And if you have followed any of the last streams or read the articles I've written, you know deposit is for paying the gas to bundler, and stake is for reputation purposes. I also don't know the exact details of how stake works, but that's the main thing, where you spend the deposit but stake doesn't get spent or slashed or anything like that. So address payable, address payable. Now what? Receiver equal to payable MAC address and then string receiver. UN 256 withdraw amount 1 ether, and we can call entry point dot withdraw to. Yes, we can pass receiver and withdraw amount, and here we can say vm dot uh, expect revert. Just a string, it's not a custom error, so we need to copy the string, paste it. Okay, that should do it. Yes, that condition is completed. Function test withdraw to works, or yeah, works is better. Sorry, withdraw to works. Public. Now we know create payable receiver and withdraw amount variable. We can go down and say what what we want. Next is withdraw. No, make deposit. Third is withdraw deposit and check event emits. Check emitted events. Lastly, check no do the assertions, balance checks. Okay, now we know we need to do address payable receiver payable. Yeah, I should follow like the dry principles. Do not repeat yourself, but it's much easier to repeat myself in tests. Even 256. Yeah, even 256. Withdraw amount equal to 1 ether. Go down, make deposit. So entry point dot deposit to, let me check what, yeah, deposit to the address this, and we can pass value withdraw amount. Then we can do withdraw and check for emit. So expect emit. Now we can check which event is getting emitted. It should be withdrawn. That's the event. Yeah, withdrawn. Where is withdrawn event? Yes. So first is indexed, second, third is not. So true, false, false, true, and address of the entry point. We know withdraw amount, we know account, we know the amount. Two of them we are passing. Sorry. Oh no. Account withdraw address. Okay. Account is whose deposit we are withdrawing. So true, or false, false, true, address of entry point. Then we can do entry point dot, oh no, we have to do emit. I stake manager dot withdrawn. Then we say address this, then the receiver, and then withdraw amount. Okay. Now we can call the function. Withdraw to with receiver and withdraw amount. We can do the assertions. Where? Oh, no. Yeah, we are using it. My system is lagging. It's not system, the VS Code is lagging because it's a big file and multiple applications are running. So it's not it didn't recognize for a second what's happening there. Okay. Now assertion checks. You can say entry point dot get deposit. No, balance of address this, and I need one more variable. So UN256 expected deposit amount after withdrawal equal to 0 ether. We can pass that variable here and assert equal to receiver dot balance is withdraw amount. Yeah, with that we are done with that test case, at least writing it. Let's run the command and see if it works. Yes, it works. Now we have the final required statement. this one, which should revert on failed ether transfer. We already know what to do. Test withdraw to reverts on failed ETH transfer. Public create receiver that. Okay, what's happening? Okay, I don't know why that thing opened. Receiver that fails on ETH transfer and withdraw amount. Okay, address payable receiver equal to payable address new reverts on ether transfer or ETH transfer. What's the exact? Oh, not transfer, received. Okay, the name was wrong. Yes, with that we have that. Next is UN256 withdraw amount 1 ether. Second step is add deposit. Entry point dot deposit to and address of this contract. We can say value withdraw amount. Third is do the assertions and withdraw deposit. We're going to say vm.expect revert. What was, yeah, the error is just a string again. I don't like that. You can have custom errors with require statement, but maybe that's a very newer version of Solidity, not the version that we are using. So maybe that's why they they are not using it. So we can say entry point dot withdraw to and say receiver and withdraw amount. Okay, maybe I should refactor these things so my VS Code won't lag. Yes, that's finished. Like this is done. Should we put like these? Yeah, I feel like we should. We have few. Yeah. So remove this from here. Core new file take manager dot t dot soul. Then we can create like pragma 0.8.24 contract take manager test is test, and we can pass this. We need a setup function Yeah, and we need bunch of imports. Import test, sorry, test from forge std slash test.sol. Now that's done. We need the entry point. We need to import entry point. Entry point, it's src slash core slash entry point dot sol. Yeah, that's correct. Entry point private entry point function setup public entry point equal to new entry point. Yeah, let's what else? Okay, we can remove these console statement. We need stake manager, which is import stake manager source slash interfaces slash stake manager dot sol. Okay, there is one more error. Where is that? It's here. Okay, we don't have that contract. How should I structure that? I should I do this like reverse on received from dot slash entry point. Yeah, that works. Let's try to run this. The flag will change. It will change from dash dash mt to dash dash mc. Let's see. Let's see. Yeah, we are up to 91% lines, 92%, and branches 100%. Okay, I think that works. Let's change this to, I don't know if this will work or not. Let's see. So what we did is we just, let's go here. Yeah, you can see we just ran the coverage and created report for that one single test contract, and it will show what we what we are not covering here. You can see in the unit tests we are not covering this, where we are not calling this. We were calling it in entry point, but not in stake manager.t.sol, the file we just created. And this function, it's internal function, so we can't access it, but also it's a view function. And get stake info, we are getting stake info somewhere. No, we are not getting stake info anywhere, but we can if we want. Yeah, it's deposits, yeah. It's basically get deposit info, but just for stake. And then there is a stake info struct. Is it imported from somewhere? Let's go back to VS Code. So here we the view function. Where is view function? This view function. Okay, it's in the R stake manager. Yeah, we are already checking that and from the deposit info. Even if we are not calling that particular function, we are checking the particular the details of that particular struct. So let's write one more which sends ether to the entry point directly, and it'll call the receive function will get called from it. Let's go here. Function test direct deposit works. Public, then we can say entry point dot call. Sorry. Yeah, okay. So here we can define a variable called deposit, which will be 1 ether. We can say we are sending value deposit, okay, and it's boolean success. Yeah, that's about it. Success. Just a second. If success, then no, if not success, you can just ignore it. It will be. So we don't need to handle that case. How to fix the problem? Okay, ignore it. And we are gonna check the deposit, I think. How to suppress warning and Solidity files. How to suppress a warning. I can't find anything on here on Google, or I just don't have patience to find that. I am probably gonna find something, but I'm just gonna ask ChatGPT how to have warning in Solidity file. How do I suppress it? Question mark. I'm using Foundry. Oh no. Okay, let's check the deposit. Assert equal to entry point dot balance of address this should be should be deposit. Yeah, deposit. Okay, now that's done. Deposit field. Okay, let's run this. Yes, so we have more like better coverage. Simple, like few lines. We covered only lines. Yeah, you can see 94, 93, and only one view function is remaining. So we can we can ignore that for now. We'll test it afterwards. Yeah, I think that's about it for this stream. Tomorrow we're gonna start writing the factory contract. Let me brush up on like create to and how the factory works. But uh, tomorrow we are gonna write the account factory, and that will allow us to test more functions from entry point and go after like other other things like what else was there, sender creator, nuns manager is 100% covered, base account. Yeah, we also have this. So what, internal external override. Okay, this is just abstract. Okay, this is abstract, right? Yeah, abstract was not covered in that. Let me run the, yeah. Okay, or we can figure that out tomorrow. Yeah, hopefully you enjoyed the stream, and see you guys tomorrow.